All right, this is lesson, it's actually 3.4, finding the equation of a line given 2 points. So we have a warm-up problem. Tank holds 100 gallons of water. It leaks 5 gallons every hour. Make a table and graph that represent the volume of the tank over time. And then there are a number of questions that you're going to answer for that. So go ahead and pause the video. Go ahead and start with that, making the table, and then go through and answer those questions, and then we will proceed from there. Okay, so hopefully you've paused the video and worked through those problems and now ready to go over this. So we know that the tank holds 100 gallons of water. That's going to be our start value. And then it's leaking 5 gallons every hour. So I'm going to go ahead and put in for hours 1, 2, 3, and 4, and of course 0. You always want to start at 0. And 100 goes with 0 because this is at the start. And then this would represent the volume after 1 hour has passed. And so this is going to drop to 95. Then hour 2, that's going to drop to 90. Then 85. Then 80. And so what we see here is we are decreasing by 5 as the x value is increasing by 1. So our rate of change, our change in y over change in x, winds up being -5 gallons for every hour. Now if we drop the units and simplify the fraction, we get -5 as our rate of change or our slope. And then as I mentioned before, this is our start value. So how can we see the start value in the table and in the graph? Well, for the table, obviously we see it here, right, is the start value is the y value when x equals 0. So it is 100 gallons. Now, for the graph, we'll need to make a graph for this to be able to see that. So let's go ahead and do that now. In class, we went ahead and passed out a sheet of graph paper like we've been using for the other lessons. This is going to be hours down here at the bottom, and this is going to be gallons. Oops, I really do want to start with a capital G there. Anytime we have a label, oops, I just tore right through that paper. Boy, that was one strong eraser. Okay, so anytime we label, we'll want to use capitalization like we would with a title when we're labeling our axes. And then I'm going to go and start labeling 1, 2, 3, 4, 5, 6, and I'm just going to go by ones for hours all the way over. And then for this, I think I'm going to go by, see, if I go by fives, that'd be 10, 20, 30, 40, 50, 60, 70, 80, 90. Yeah, that would take 100 at the top. So I'm just going to pause the video real quick. Or actually, I'm going to skip over to have this graph already finished. I have the scale, just like that, I have the scale finished. And we're going to start here at 100. I do want to note on this scale I did go by fives, but I didn't label every single one. You don't have to, so I just labeled every other one by tens. So this would be 5 and 15 and 25. You can put those in there or you don't have to, it's up to you. But we're going to start with our start value, and then we set at 1, it drops to 95. This is based off of our table, right? And then at 2, it's at 90, and at 3 hours, it's at 85, and at 4 hours, it's at 80. And so we can see the pattern that is developing from the graph. And I could actually just continue to follow this pattern all the way down. And we can continue all the way till it hits the x-axis. Now, back to the question that was asked. How can we see the start value in the table and then in the graph? Well, we said we still saw the start value in the graph, where when x equals 0, it's the y value. For the graph, it is the y-intercept. So where it hits the y-axis, which is going to be right up here. For B, what does the slope represent here, and why is it negative? Well, the slope is how fast the tank is losing water. The slope is negative because the water level is dropping or decreasing. The water level is decreasing. All right. Our next question here, how do you know when the tank will be empty? Well, there's three ways we could do this. On the graph, actually, it's pretty easy to tell. You can just watch the graph where it gets down to 0, so we can see that the water level is decreasing, and when it gets down to 0, that happens at 20 hours. So we can see that on the graph. On the table, we could continue to bring this table. We can see that's dropping, and we could just bring this all the way out until we got to 0. But that's probably the harder way to do it. And then the last way to do it is we could use the equation. We haven't done that yet. Let's go to D and find the equation. What is the equation of the line that represents a situation? Well, remember we've been using y equals mx plus b, where m is the start value, m is the rate of change, and b is the start value. Well, we know the rate of change is -5. We found that up here. And we know the start value is 100. So we could also use this equation to find out when the tank will be empty, because the volume will be 0. Y represents the number of gallons in the tank. So if I go 0 equals -5x plus 100, so I plug in 0 for the number of gallons, I can solve for x, which is the number of hours, and find out when the tank will be empty. I'm going to go ahead and flip the -5x, so it becomes a 5x. And then to combine it with a 0, it's still 5x, right? And then we will divide both sides by 5. And 100 divided by 5 is 20. So we do get that 20 hours that we saw on the graph. What is the volume of the tank at 12 hours? Well, once again, take your equation, -5x plus 100. And in this case, we plug in 12. Now, where does 12 get plugged into? Is it x or y? Well, this is 12 hours, so x is the number of hours. It only makes sense to plug this in place of x, because y is gallons, and they didn't tell us the number of gallons. And we'll go ahead and solve this. If we multiply -5 times 12, that's a -60. And then we'll combine, and that's a war. Positives win. And if we subtract, we find the answer is 40 gallons. So at 12 hours, the tank will only have 40 gallons left in it. Oh, sorry. Apologize, I didn't have all of that shown up there. So once again, we plug 12 in for x, multiply, we get a -60, and then we combine those. That's a war, positives win, and you have 40. And when will the tank be empty? I guess we kind of already answered that up here, right? So I guess, how do you know when the tank would be empty? I guess the answer to this question is the volume is 0, right? Y equals 0. And then here we were supposed to do this. So I guess I'll erase this. I kind of jumped the gun on that answer. So this work actually goes right down here. How do you know when the tank will be empty? Well, y equals 0, right? Or in other words, that has 0 gallons in it. All right, that is the warm-up problem for lesson 3.4. Please continue on to the video for page 2.